Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see EPR paradox. Earlier we have seen Schrodinger's cat experiment, which is one of the thought experiment that explains weirdness and absurdity of quantum mechanics. Similar to Schrodinger's cat experiment, EPR paradox is also a thought experiment which demonstrate that quantum mechanics is not complete physical theory, and it has also root conceptual difficulty as it cannot incorporate theory of relativity within the formalism. This paradox was jointly proposed by Einstein, Podolsky and Rosen in 1935. At that time, there was a hot debate between Albert Einstein and Niels Bohr. At that time, Bohr and his colleague came up with the Copenhagen interpretation, which involves uncertainty, probability, and such weird ideas. That is why Einstein was unhappy with that interpretation. And once Einstein told regarding that interpretation that God doesn't play dice, to reply Einstein, Bohr replied that don't tell God what to do. So there are several controversies regarding absurdity and weirdness of quantum mechanics happened at that time. This interpretation or this paradox involves the idea of quantum entanglement, in which two particles are entangled with each other in such a way that both can communicate with each other with the speed greater than speed of light, which violates basic hypothesis of theory of relativity, according to which speed of light is always constant. It is known as principle of locality. So these paradox explain non-locality. So to explain this paradox, David Bohm came up with one more thought experiment or one more hypothesis, in which he hypothesized one particle which is completely unstable and having zero spin. This unstable zero spin particle is decayed into two particles which are heading in the opposite direction. Suppose if we demonstrate particle 1 as A and demonstrate particle 2nd as B, and suppose particle A has plus 1/2 spin, it means particle B must have minus 1/2 spin. Earlier we have seen in Copenhagen interpretation that until the measurement is made, particle doesn't have definite value. So here both particles are in a superposition of possible state with equal probability of having either positive or negative spin. So here is the point where paradox arises. Suppose if you measure particle, it means particle A's quantum spin gets set by measurement, and somehow particle B would know regarding particle A's spin, and it would know what spin it should get or what spin it is supposed to set on or take on. It means instantaneously here communication between particle A and particle B is happened. It means basic hypothesis of theory of relativity, that is speed of light is constant, is violated here. So in quantum entanglement, more than speed with more than speed of light, both particles can communicate with each other, and that is why Einstein was unhappy with this idea, because it violates principle of locality. So this is how EPR paradox works. In this diagram I have shown both particles having plus 1/2 and minus 1/2 spin. Here particle A has plus 1/2 spin, particle B has minus 1/2 spin. These two particles are created from, as we have seen, unstable zero spin particle, and this was the experiment or thought experiment which was given by David Bohm. So EPR paradox is very important in physics, modern physics and quantum mechanics. From EPR paradox, there is another concept which is arised, that is Bayes' theorem or Bayes' inequality. And to demonstrate Bayes' inequality, few years ago, scientists got Nobel Prize in Physics because of EPR paradox. Here, strange thing is that in physics, in experiment or in laboratory, quantum entanglement is seen. That is why quantum entanglement phenomena is real. So here thing is that whether principle of locality is true or false. I will consider or I will explain this concept in future in my other videos. Thanks for listening and watching. If you like my channel, please subscribe my channel. If you have any question regarding this paradox, you can ask in comment section. Thank you very much.